Today's video lesson is going to focus on how to solve a polynomial equation, and then in the latter part of the lesson we'll look at how to construct polynomial equations that have particular solutions. So let's start out with how to solve polynomial equations. Well, just before we get to that, I think I might just jump to a page here. I want you to recall from quadratics, let's suppose that I had x squared, so if I had the quadratic x squared, take away 2x, subtract 8, equals 0. So now it's a quadratic equation because it has an equal sign and it's equal some number here. Well, we could solve these by factoring. X subtract 4, x plus 2 equals 0. And then this is the premise that we applied. We said that the only way to multiply factors together and the answer turned out to be 0, one of the things you're multiplying by is 0. So if that's the case, in this case we would have said, well, maybe x take away 4 is 0, which could only happen if I figure out what makes this equal to 0. So you just solve for x. Oops. X would have to be 4, or if x wasn't 4, x could have been also perhaps x equals -2. If you'd put either -2 in the original or in either of these factors for x, you'd get 0, or if you put 4 in for either of these. And again, it's based on the whole premise that if you have two things multiplied together and the answer is 0, one of them has to be 0. Could be there or it could be there. Well, that premise isn't going to change if we expand and have 3 things multiplied together, still equal to 0. The only way you can multiply 3 things together and get 0 is if one of the 3 is 0. They don't all have to be 3, but one of the 3 at least has to be 0. Well, that wouldn't change if I had 4 different factors multiplied together and the answer is 0. One of those 4 has to be 0. Using that premise, if we're going to be able to factor this polynomial down, well then if we can get it written as things multiplied together equals 0, well then one of the factors has to be equal to 0. So we're going to take what we learned from the factor theorem in the prior video lesson, and we're going to now apply it to this, basically the same situation, except it's now an equation. So we're actually going to solve and get answers for x. Whereas before we just got the factors and stopped at that point. Alright, so let's take this one and we'll start out with trial and error, and let's see if we can get a number here that makes this equal to 0. Let me have a look. Let's try. So the only possibilities would be plus or minus 1, plus or minus 3. Doesn't look like 1's going to work. It's not going to give me a 0. I don't think a -1's going to work, so it must be a 2 or a -2. Let's try -2. -2 cubed. Oh my goodness, I'm going to need my calculator. Give me a second. Alright, so I went and got my calculator and did out this calculation. I had made, what I meant to say here was not -2. It had to be a factor of 3. The only factors of 3, as I said earlier, are plus or minus 1, plus or minus 3. So I just looked by inspection. I could tell 1 wasn't going to work. Does any way make that equal to 0? So then I said, well, it must be either plus or minus 3. I tried -3, and voila, it worked. Meaning when I put -3 in for x, remember this is the remainder. It's called the remainder theorem. And if there's no remainder, it tells me that putting in -3 is generating a factor, something that goes evenly. And we know from our work in the last section that that must mean x plus 3 is a factor. So we've got one factor. Well, let's find the other factor. Let's do a synthetic division over here. 16, 48, -1, and -3. Our factor is plus 3, so this is going to be a positive 3. Bring your 16 down. 3 times 16 is 48. 0. 3 times 0 is 0. -1 take away 0 is -1. -3, 0. So that's a good sign. That's going to give me 16x squared, no x term, minus 1. That's my other factor. So I have this factor and this factor. So instead of writing this as it is, we're going to write it as two factors, x plus 3 multiplied by 16x squared minus 1. That would be equivalent to this. Well, that has to equal 0. 16x squared subtract 1 factors even further, so I'm going to keep going. X plus 3. This is the pattern of difference of squares. 4x subtract 1. 4x plus 1 is equal to 0. Now we are at the situation I talked about in the beginning. I have 1, 2, 3 factors multiplied together, and the answer is 0. The only way to multiply things together and get an answer of 0 is if one of them is 0. Now this step here, you can do it in your head if you like. You should be getting enough experience at these now after your Pre-Calc 11 course that you can just look at this and say x must be negative 3, x must be a quarter, x could be negative 1/4. Those would be what are referred to as the roots of this equation, the zeros of the polynomial, the solution set, all asking you to do the same thing. Determine the value of the variables that would make the equation a true statement. Okay, so there's not really a whole lot new there, other than we took what we learned about factor theorem, synthetic division, some factoring from grade 11, and the whole principle of the only way to multiply and get an answer of 0 is if one of your factors is 0, which we kind of use that principle in prior courses as well. So it was just kind of piecing together some information we had already gathered over the last couple of courses of study in pre-calculus. I've already talked about that stuff. Okay, so let's have another look at an example here. So if I had 4x cubed plus 1 equals negative 8x squared minus 5x, and I wanted to solve this polynomial equation. Well, much like quadratics, you must always make it equal to 0 first. So let's rearrange. 4x to the third plus 8x squared plus 5x plus 1 equals 0. Well, the good news is I've only got two options that could possibly make this equal to 0. In theory, they would be plus or minus 1. That's the only factors of 1. Well, looking at the fact that these are all added up and the answer is coming out to 0, the only possible thing that could work here is negative 1. I'll double check it, but it has to work. If it factors, maybe it doesn't factor. Negative 1 cubed is negative 1 times 4 is negative 4. Negative 1 squared is 1 times 8 is a plus 8. 5 times negative 1 would be a negative 5 plus 1, negative 9 plus 9. It works. Therefore, x plus 1 is a factor. All right, let's do our synthetic division over here to the side. So I'm going to divide x plus 1 into 4, 8, 5, and 1 are my coefficients in descending order. 4 times 1 is 4, 8 take away 4 is 4, 1 times 4 is 4, 5 subtract 4 is 1, 1 times 1 is 1. Perfect, I get 0. Now this is the polynomial 4x squared plus 4x plus 1. Okay, so now I've got this factor, x plus 1. If I was to multiply it by this factor, I should get my original, so I can change that original equation to this. Let's check this. Will this factor? Yes, it will. It's actually a perfect square trinomial. So this is factored out to be 2x plus 1 all squared is equal to 0, which would lead us to two possible answers. X could be negative 1. That would make this 0. Now the fact that you have a squared on this makes no difference whatsoever, because 0 squared would still be 0, which would make this 0 multiplied by who cares what this is. I would still get 0 for an answer. So don't be thrown off by the exponent. You still just figure out what would make 2x plus 1 equals 0. If you can't tell by inspection, solve it out. 2x equals negative 1, just move that over. Divide both sides by 2. There's your other possible answer, negative a half. So negative a half and negative 1 would be our two possible solutions. Continuing on with another one, let's have a look at this one. Let's see, the instructions say identify the points where the graph of f of x crosses the x-axis. Crosses the x-axis is fancy talk for find the x-intercepts. Find the x-intercepts. Now, we're supposed to know how to do that, relatively easy. What you do is you fill in 0 for the y. Now, sometimes a less experienced student than maybe yourselves might say, well, I don't see a y anywhere. Well, we know that this f of x is really the same thing as what does y equal. So that's my y equals. It wants me to replace that with 0. So I'll do that. 0 equals x to the third plus 6x squared, subtract 2x, subtract 5, and off we go again. Now it's the same as the last couple of examples. I need something that I can put here for x, so I've got two choices, plus or minus 1, plus or minus 5. By quick glance here, I think x equals 1 is going to work. Let's try it. X equals 1 will give me 1 plus 6, subtract 2, subtract 5. That does work, which tells me that x subtract 1 is a factor. Synthetic division to get another one. This will put a minus 1 in front, a 1, a 6, a negative 2, and a negative 5. Bring down your 1, multiply, subtract, multiply, subtract, multiply, and you subtract. That gives me x squared plus 7x plus 5. That would generate the two factors, x subtract 1, x squared plus 7x plus 5. Those two multiplied together give me 0. All right, something a little different is going to happen here. If the question said factor the following, this would be factored. This doesn't. The issue here is that this trinomial this time, unlike the other ones that we've done so far, it won't factor any further. However, it didn't say find the factors, it said solve, or find, in this case, the x-intercepts. Where's across the x-axis? So I know across at 1. I need to figure out, so this one's easy, x minus 1 equals 0. Well, I know there's one answer. Crosses the x-axis at 1. However, I can't easily factor this, but the good news is it's a quadratic. And we have learned a trusty old formula back in pre-calc 11 called the quadratic formula, which you are expected to be able to rhyme off. Feel free to sing the song. Those of you that like the song, I won't sing for you and hurt your ears. Here we go. So there's your quadratic formula. X is equal to negative b plus or minus the square root of b squared, subtract 4ac, all of that divided by 2a. Fill in the correct values. X equals, so there's your b value, negative 7 plus or minus b squared would be 49. Take away 4, a is 1, c is 5, all of that over twice a being 1, so that's just going to be a 2. X would be negative 7 plus or minus, this is going to be 49, subtract 20, the square root of 29 over 2. This doesn't reduce any further, that radical. We will just leave everything as it is. So those are your three answers. 1 is one answer. Negative 7 plus the square root of 29 divided by 2 would be a second answer. Negative 7 subtract the square root of 29 would be your third answer. So this one has 3 x-intercepts. And unless there was some reason I needed to maybe draw the graph or something, I had to figure out where this is as a decimal. unless I'm asked for that, I would just leave it as a radical, and this is simplified as far as it'll go. All right, so don't forget about the good old trusty quadratic formula. You are expected to know that. I just grabbed a sample question from a test. So this is off of an old test. Now this one's a little bit more, we kind of look and say, oh, that looks a little bit more complicated. Not really. The only difference here is you got to do a little bit of expanding and moving things around before you can get going. So we're going to distribute the 4 in here. We'll get 4x to the third minus 20x plus 16. Your equal sign. 8 is distributing into these two. So 8x to the third plus 8x squared. These two would just stay the way they are. And now we'll start rearranging. 4x to the third. I always like to have my highest exponent positive. So let's move the 3 on the left over to the right. So I'm going to go 0 equals 8x to the third, take away 4x to the third is 4x cubed. A negative 26x, and I add 20x. That will give me minus, oh, what am I doing? I missed the x squareds. Let me back up for a second. The only x squared I see is right here. So that's going to stay there, plus 8x squared. Now let's do the x's. A negative 26, add 20, that's subtract 6x. I have a 16 here, that's going this way. So that's going to give me a subtract 6. One thing that I notice here that you should watch for, notice that all of these 4, 8, 6, and 6 are divisible by 2. Because it's an equation, one of the things you can do with equality is, as long as you do the same thing to both sides of an equation, you will still have equality. So if I divide all of these by 2, I'm allowed to do that, provided I go to the left side and also divide it by 2. Well, the nice thing about the left side is that it's 0. And if you divide 0 by anything, it's still going to be 0. So this equation would now switch and become, let's just put it so it's going to be 2x cubed plus 4x squared, subtract 3x, subtract 3 equals 0. Now we will try and get a factor of this. Let's try x equals 1. I'm just looking at it quickly. I think it's going to work. 1 cubed is 1 times 2 is 2. 1 squared is 1 times 4 is 4. 3 times 1 is 3. Minus 3. 6. It works. Which tells me x subtract 1 is one of the factors. Off we go over here, do our synthetic division. Minus 1, 2, 4, negative 3, negative 3. Bring down your 2. 6, minus 6, 3, minus 3, so that works. X subtract 1 multiplied by this, which is 2x squared plus 6x plus 3. That has to equal 0. 2 multiplied by 3 is 6. There are no two numbers that multiply to give 6 and add to give 6. So therefore, this won't factor. Doesn't mean it doesn't have roots, just means it won't factor. Now we'll check it then with the quadratic formula. X equals negative b plus or minus b squared, which would be 36, subtract 4 times a times c. All of that would be divided by twice a. So let's see, we've got negative 6 plus or minus. What do we got here? 8 times 3 is 24. 36 minus 24 is going to give me a 12 underneath here. This would be 4. Now, when you get to pre-calc 12b, we're preparing you for big-time mathematics, calculus, and that good stuff beyond high school. Well, a good mathematician is never going to leave something like that. They're going to reduce it. X is equal to negative 6 plus or minus. This reduces to 12 is 4 times 3. So in simplest form, that radical is 2 radical 3. Got a 4 down here. Now 6, 2, and 4 are all divisible by 2. Negative 3 plus or minus radical 3 over 2. So there's two answers. Negative 3 plus the square root of 3 divided by 2. Negative 3 take away 3, the square root of 3 divided by 2. And the other one from way back up here was our first initial one, which was really easy. That's x equals, excuse me. So as I said, that'll give us x equals 1. So we have 1 and, oops, these other two roots here. Okay, so that's how you take what we know now about factor theorem, remainder theorem, quadratic formula, solving by factoring, piece it all together, and we solve polynomial equations. Now, the next thing we'd like us to be able to do is build an equation that has a particular set of answers that I would like it to have. It's a great thing to know how to do as a teacher, because often I'll want to build an equation on a test and say, well, I want these to be the answers. I want the answers to look like this. So I start with the answers, and then I work backwards, and I build an equation that has a certain set of answers. We did it with quadratics as well. So I want you to think of, again, I'll maybe go to a blank slide for a second and relate to prior knowledge. Let's suppose we go back to an easy one last year. Let's say you had x squared minus x minus 2 equals 0. You solve that out, you get x minus 2 multiplied by x plus 1 equals 0, and you get x equals 2 and x equals negative 1 as your solutions. So you essentially started with the quadratic and you worked your way down to get these. Well, what we would like students to be able to do is put their brain in reverse and start here and work their way back up. So imagine I took an eraser and I erased all this stuff here. It was gone. The only clues you had were what the answers were, but I wanted you to work back and figure out what the quadratic was that gave you those answers. Well, looking at what we had, the only way to get x equals 2 is if you get x minus 2 as a factor. An easy way to do this, in your head, always think, I want to figure out what this must have been when it was equal to 0. So you just take your 2 and move it back where it was. So in this one, for example, take your negative 1 and move it back where it came from. X plus 1 must have been there, and then that would be equal 0. So then once they're both equal to 0, I know that those two multiplied together must have given me the original expression. I can expand x squared plus x minus 2x minus 2 equals 0. And now I can see that the original equation that would give me those two answers must have been 0. That. So I started with my solutions and I worked backwards. Well, we did it in quadratics, but we only had 2 factors. So the only difference is we may now have 3, 4, 5, whatever. Probably only going to be 3 because we don't have to be too long of an expansion. Okay, so if I get negative 2 as an answer, that means that x plus 2 must have been a factor. If I get 1, that means x take away 1 must have been a factor. And if I get 5, that means x subtract 5 must have been a factor. So just think about it. How do you know that? Think about this. If this was a factor, and I said to you, what makes this bracket equal to 0? Hopefully you'd tell me it's negative 2. This bracket would have to be a 1. This one would have to be a 5. What I'm trying to do now is build a polynomial. This is not a polynomial. A polynomial is a series of terms added and subtracted. They're not factors with all positive exponents. So I'm going to pick 2 of them. Let's pick the first 2 and let's multiply. X times x, x squared. X times a negative 1 is a negative 1x. 2 times x is 2x. So when I combine those together, I'm going to get a plus 1x. 2 times negative 1 is minus 2. And then I'm going to have my binomial here, x subtract 5 equals 0. Well, now I'm going to take this trinomial and multiply it by this binomial. X squared times x is x to the third. X squared times negative 5, negative 5x squared. X multiplied by x multiplied by negative 5. Now negative 2 times both of these. Negative 2 times that is a plus 10. Collect any like terms. I will get x to the third, take away 4x squared, subtract 7x plus 10 equals 0. If I was to solve that equation, those would be the roots, or the solutions, or the zeros as they call them here on the slide. All right, let's take this one. So this one had no fractions in it. So this one's got a couple of fractions in it. So let's see if we can manage that. Well, let's start with x equals 2. So if x equals 2, as I showed you earlier, -2, x equals 2, it's really nothing more than you moving this to get 0 here. So move that 2 over there, I'd get x minus 2 equals 0. Now if you can't tell what this is by inspection, once you kind of get the hang of this, many of you will be able to just look at this and tell me what they are, but if you can't, that's all right. Go x equals, keep getting ahead of myself, x equals 1 over 3, and now rearrange this to make it equal to 0. So I'd have to multiply both sides by 3. 3x would equal 1, bring my 1 over. That means that 3x minus 1 must have been the factor to give me 1/3 as a solution. This one, x equals -2/5. Multiply both sides by 5, and then move your -2 over. 5x plus 2 must equal 0. That tells me these were the 3 factors that gave me those 3 solutions. Now write them out as a polynomial, or how the factors multiplied together that would give you the polynomial. And then it just becomes an exercise in expanding. Again, not something you're being taught in Pre-Calc 12B. We would just expect students of your caliber to be able to expand this. Let me get rid of this mumble jumble down here and move that. So that's gone to give us room. Okay, so we're going to switch colors. So I'm going to multiply the first 2 here. I'm going to get 3x squared. Subtract x. Let's do that in our heads. God love him. I can still remember my grade 11 and 12 math teacher, Mr. Shannon, saying, surely by the time you get to the grade 11 and 12, you can keep track of 2 numbers in your head for about a matter of 10 seconds and combine them. And this is what he meant right here. Go x times -1. Keep it in your head. Don't write it down. So it's a -x. 2 times 3x is 6x. So a -1x and a 6x. That's going to combine to give me a plus 5x. 2 times -1, that's minus 2. Still have my 5x plus 2 that I need to multiply that answer by. 3x squared times 5x is 15x to the 3rd. 3x squared times 2 is plus 6x squared. Now 5x times both of these is 25x squared and a plus 10x. -2 times both of these is a -10x and a -4. Collect like terms. 15x to the 3rd plus 31x squared. These eliminate, so they're gone. Take away 4 equals 0. There's the polynomial that would give me those 3 solutions. All right, one last little thing to show you, and it is, what do we do if the roots are not rational? Meaning they have a radical in them here that's not a perfect square, or your answers aren't nice fractions or integers. Usually if I was doing this in class, I kind of threw it out there to you as a group and say, well, could you think you could do this? The first thing students do is they say, I'm going to try and recreate the quadratic formula. Plus or minus. And you can do it this way. I'm not going to do it this way though, because there's a much easier way. And they'll say, this must be -b, so they'll say, well, b's got to be a 3. This is b squared minus 4ac, but they don't say, well, they have too many things they don't know. They look over this, say it's over 1, so a must be a half, and all that kind of, and it can work, but it's a bit of a challenge to do it that way. Watch this. This is much, much easier. All we're going to do is move all this stuff to the left side and make it equal 0. You say, what do you mean by that? I shall show you. I'm going to get rid of the -3 first. So I'm going to add 3 to both sides, which will give me x plus 3 equals plus or minus radical 5. You have to do that first. You want to isolate this plus or minus square root term. Now, the reason you're going to do that is because students will say, well, yeah, but there's two different numbers here. And they're absolutely right. There are two different numbers there. But if I put the whole right side in brackets and I square it, would it make any difference whether I had a plus root 5 or a negative root 5 after I square it? It wouldn't make one bit of a difference. You're going to get the same thing. Now, with equality, you have an equal sign. You can't just square the right side and not do anything to the left side. And remember, you don't just square each one. You put the whole side in brackets squared, which will then require us to use the three-step rule. Square the first, multiply and double, square the last one. Excuse me. Square this one, I'll just get the number 5. Move your 5 over, x squared plus 6x plus 4 equals 0. There's the quadratic that gave me that solution. Nice and easy. Move everything to the left and make it equal 0. So if I get into that, so that's quadratic. If I extend that to polynomial, so that just means I get something like this, which here's some ugly irrational solutions, and I've got one rational one over here. So I'm going to combine those two together and get the two possibilities. So let's do this one first. I got to get rid of the 5 on the bottom. So it's going to be 5x equals negative 1 plus or minus root 3. Now I'm going to move the minus 1 over here. So 5x plus 1 is plus or minus the square root of 3. I'm going to square both sides to get rid of that radical 3, the plus or minus, cubed, squared. I'm going to square this side as well. 25 x squared plus 10x plus 1 equals 3. Bring your 3 over. So I have... So that quadratic equation would give me those roots. Well, this is linear, so same thing. Let's make it equal to 0. 5x equals negative 3. Move your negative 3 over. 5x plus 3 has got to be equal to 0. Meaning this multiplied by this must make up the original polynomial to give you those solutions. All we now do is take 25 x squared plus 10x subtract 2, and we are going to multiply it by 5x plus 3 and make the 2 equal to 0 to build our equation. So 25 times 5 is 125 x to the 3. 25 times 3, 75 x squared. 10x times 5x, 50 x squared. 10x times 3 plus 30x. Negative 2 times 5, negative 10x. A negative 2 times 3 is a negative 6. Now if I group this all together, 125 x cubed plus 125 x squared plus 20 x's minus 6 equals 0. There would be a polynomial equation that would give you these roots that you see here. All right, so I've shown you how to start from the beginning, like this. Sorry, here. Start with a polynomial equation, go through backwards here with synthetic division, remainder theorem, and get solutions. And then the second thing I showed you is how to do basically the opposite. Start with the solutions and build the equation that has those particular solutions. As always, make sure you have done the practice material. If you do have any questions, please reach out either through your class notebook or through email or through questions in class, and we'll hopefully get you pointed in the right direction. Thank you.